All right. Well, hello, everyone, and welcome to the fourth Tech Talk in the UI Library Data Hub's Tech Talk series. These talks aim to expose the UI community to topics, issues, and tools that will help them produce their own work. To that end, this week we have Dr. Tanner Varrelman from Research Computing and Data Services, and he's going to be talking about Redis and how it can help improve researcher workflows. So, Tanner, take it away.
Thank you for the introduction. So as the title suggests, today we're going to be learning about the power of Redis. There's going to be a high-level slide deck that we're going to go through just to describe what Redis is, the use cases, some of the data types, and then we're going to get right into some coding in Python. So at the end, there's going to be a link to the GitHub repository that has all of the code, the slides, and everything for this presentation. So again, we're going to start with a quick introduction to Redis and in-memory databases in particular. We're going to talk about the different data structures, the benefits of using this software, and then we're going to get right into some of the installation instructions, how to connect to this database, and then we're going to get into those code examples. So you may be wondering, what is Redis? Well, Redis is an in-memory database that is often used as a data cache. It can be used as a vector database and also a document database. These are just a few examples. There's other functionalities such as a message broker and things like that, so your software can communicate and schedule jobs effectively. But it's important to note that large companies such as GitHub, Stack Overflow, Instagram, Snapchat, they use Redis as a data cache. And so in the next slides, I'm going to describe what these specific functionality are and why massive companies like GitHub and Stack Overflow are using Redis. So before we do that, though, we need to understand what an in-memory database actually is. And so this diagram on the right here shows the in-memory database on the left, where our main data is stored in RAM, and then there's a backup that is stored in disk for that data. On the right is a traditional database where there's the cache for that data in RAM, and then on disk is that main database. Looks like I have my bar here is covering that up, so I'm going to try to hide this if possible. Can I? There we go. Okay, perfect. Sorry about that. Now, hopefully this diagram is a little more clear. Okay, so now that we've seen this structure, essentially what this means is that in-memory databases eliminate the need to query data from disk, which results in faster response times. You may think that your database is really fast when it's not that large, but when you're dealing with millions, tens of millions, and 100 millions data points, retrieving data from disk can actually be really slow. So to have performant applications, it makes sense to have, say, a cache of your data stored in memory. Okay. So what is a cache? How does this work? So this is one of the kind of traditional use cases for Redis. And so looking at this diagram here, we have MySQL on the far right. And so this is our on-disk database that stores all of our data. But say there's certain data that are queried very regularly. We know what those data are, and we want to be able to extract those data rapidly. Well, this is where a cache comes into play. And so that is that red stack there in this diagram. And so for commonly used data, you can look in the cache, extract that data, and you don't have to pull that data from the database that is on disk, right? So this is where those large companies get that performance that they're looking for, is they cache their data. So that is one of the traditional use cases. Something that's becoming kind of more used is vector databases. And so I'm not as comfortable with the term with vector databases. So if there's any corrections for this description, let me know. I know we do have a vector database expert in the audience here. So essentially, a vector database stores vector embeddings. And so these embeddings are a numeric representation of words, sentences, and the meaning of such sentences. And how you get these embeddings is through machine learning models. So on the right in this diagram, you can see we may have some audio data, text data, or videos. Our model then turns those data into vector embeddings. When you store those data in something such as Redis, there is this kind of concept of semantically similar embeddings are going to be closer to one another in that numeric space, which allows you to perform things such as semantic searches using vector databases. And so this is really commonly used with LLMs. Okay. And so kind of the final use case is Redis as a document database. And so document databases, typically called NoSQL databases, and there's many other ones out there. So you may be familiar with, say, MongoDB, and that is an example of a document database where you store data that looks like JSON, right? And so when you think of a document, you may typically think, oh, well, I'm going to store my PDF in there. It really means, okay, you have a document where the information is stored in key value pairs, right? So on the left here, we have a document where we have a book ID, which is a key, and then we have the value, which is that book ID. And you can see kind of that description in the right-hand panel. One of the benefits of document databases over a more traditional relationship or a relational database is that these document databases are really flexible. Let's say we have a whole bunch of documents and we want to add, say, another document that has a new field in it. So let's say one of our key values, there's a new one. In a relational database, that is more difficult. You would have to add it, you'd have to populate values, if not NA for the existing data. But here, you can simply update that, add that value, and you're not breaking any schemas, and everything will still work, which is a really cool aspect of document databases. Okay, so those are the use cases. Let's get into Redis's structure a little bit here. So the main structure of Redis data types is data stored as key value pairs. And the data types that Redis supports are lists, hashes, sets, sorted sets, and geospatial indices. So lists, pretty straightforward. We all know what a list is. The hashes are essentially just storing key value. Sets, very similar to, say, a Python set, where you have unique values, unlike a list. A list, you can have duplicates, but a set, you cannot. And sets are also immutable. And then there are sorted sets that are obviously sorted. I think everything else is pretty straightforward. The one thing to note is that some of the really cool functionalities that Redis has are accessed by adding these additional modules to Redis. So if you just install the base Redis, you're not going to have some of these cool features such as storing JSON data, performing full text search, and doing geographic searches as well. So it's important to note that what I'll be showing today is specifically Redis with a handful of modules pre-installed. So Redis is flexible It's faster than traditional databases. It allows for geographic queries, which we're going to see why this is important once we get to the code. It's open source, and there's also a Python client, so we can easily connect, say, our scientific scripts, where, say, we have a simulation that's generating millions of data points, and we want to be able to query those data rapidly, and we need performance. This is one of those cases where we could connect our Python script to Redis, store our data, and then extract our data as well. It's important to note that when you're looking at Redis's documentation, there's a redis.com and there's a redis.io. So redis.io is the documentation for open source Redis, and redis.com will point you to the enterprise version, which you have to pay for. So if after this talk you're interested and you go and you're looking and you're like, oh, I have to pay, make sure you're looking at redis.io because that is the open source version. So to get started, we can install Redis in a handful of different ways. But what I would recommend and what I prefer to do is I prefer to use Docker. Docker can be scary, but once you figure it out, it's actually really nice for software such as this, where we would have to install those different modules manually. Whereas here, there is something called Redis Stack, and Redis Stack has all of those modules pre-installed. And so we can just pull a single Docker image, create a container, and we can get up and going really quickly. So I'll show kind of basically how to do that here in a few minutes. Additionally, I referenced or I mentioned that we can connect our Python scripts. It's also important to note that there are other clients that you can use to connect to Redis, so you're not restricted to just Python. Although today's example is mostly going to be Redis in Python, there's also command line tools that you can use, which I have provided examples in the GitHub. So with that, let's get right into the code because that's where I think it really highlights how cool it is to work with Redis. So for the first example today, I am going to be showing how we can use Redis as a document database. And so the first step for this was me finding some JSON data that we could use so we could show how full text searches work and how we can add data. So University of Idaho Library has collections, and these collections have various related data. So for instance, here, I am using the Spanish flu collection, which has a bunch of great information, and it's a great example data source that we can play around with. So you will find here everything in blue are links that will take you to these data sources. Yeah, should be pretty straightforward if you're interested in getting started with this code yourself. Also, for reference, if you're not familiar with Jupyter notebooks, this is a Python environment where we can have markdown text with blocks of code. So for instance, here, we're going to import our important libraries and modules that we will be using today. So you'll see that I've imported Redis and then some Redis search commands that we will be using. And so the first step is to set up this client connection. So this client connection, what it does is we have Redis running in the background here. Guess I actually skipped the very important part of installing it. So I guess to backtrack a little bit. I'm sorry, this is...
You can minimize it by hitting that little, yeah, there you go.
Oops. Wish I would have done that sooner. Okay. So in Docker, this is Docker desktop. you can search for containers here. And so here you see, or images. So here you see that I searched for Redis Stack. And one of the first one that pops up here with this verified publisher checkmark is Redis Stack. So all you have to do is click the pull button after searching for it. You'll go to the images. You will find it in your list here. Let's see, where is it on mine? There it is. And then you will just simply click the run button. This will create a container for you. I named mine Tech Talk Redis. We can click on it. And this is our Redis in a Docker container. So by default, this runs on port 6379, and it will be at localhost on your machine once you get it running. There's some other parameters here, but I think I'm just going to keep it high level and just describe that this is your connection. And so once we're connected to that database, we can't by default full text search our documents that we add here, right? Because those full text search are an attribute of the Redis search module. So instead, we need to first create an index. And what this index does is it essentially describes a Redis search. So that from that module, an object that is then capable of being searched for whatever we tell it to be searched for. So for instance, here, we tell it that this is going to be an index with JSON data, and that the prefix for all of the keys are going to start with document. So this essentially just sets the stage for searchable data. We then set the schema here, which will describe which fields are going to be searchable in our JSON data. And so here we set description. Then finally, we put that all together and we create our searchable index. So the FT here stands for full text. So it essentially means we're using that Redis search module to set up this searchable index. We've named the index PyDocument IDX, and we've set up our schema. This will make more sense, however, once we run these two lines of code. And this is that collection data from the University of Idaho library. So we can see that there is an objects key, and within that object, there is a list of items. And so in particular, we see that there is, where is it in here? There's a description field, which is why I set that description above. And so the description field is what we are going to be searching and adding to be searchable. Let's see here.
Top left.
Yes, thank you. So there it is. So here the description for this first example is postcard depicting and so forth. So given that there is this objects key in our JSON data, we then iterate over that list of documents. So we access that objects list by accessing that key, and we're going to iterate over each element in there. Remember that Redis is based on key value pairs, so we need to create a unique key for each entry in the database. And so here I simply made it so our key is going to be that document. If you remember above, that's what I set the prefix to. That's going to be searchable. And then there is an identifier field within those collection documents that is that unique identifier for those inputs. With that, I then call this Redis client, that connection that we set up, we call JSON.set, and we provide the document key as well as that document that we're going to add. So this will effectively add our JSON with that unique key that we created. So once we run that, we can verify that our data is now in our Redis database. So we can call this Redis client, which again is our connection, and we can call the .keys method on it. I subsetted this to only be the first 5 elements, as we don't need to see the fully expanded list. And so here we see, okay, we have some keys. We can check the type of these keys, and we can see that we have this Redis JSON type. It's important to note that in Redis, each data type has a different command that you must call to extract that data. So let's say we have JSON data. There's going to be a specific method to extract that JSON data. If you try to use that method on, say, a list, you're going to get an error. So here, in order to search that data that we just added, we have to call that redis.ft, which again stands for full text. We need to provide it our index name, which again was our Pi document IDX, and then we can simply call .search on it. And so because we set up that index to search on the description field, we can look for words such as symptoms that are within that paragraph. So our results have a total, which shows us how many total documents were returned. And then we can print it and we can see, okay, this document had the word symptoms in its description field. Kind of cool. Additionally, you can do searching where you provide a prefix. So here we search for things that start with TH. So the star means, okay, anything that starts with TH, anything that comes after, that will be in our search results. And then additionally, we can do fuzzy searching. So let's say somebody spelt something wrong and they're trying to extract this data. So I've spelled symptom incorrectly there. We can print the results and we can see that that same document that we found above is returned again because of that fuzzy search mechanism. And so, although brief, this basically shows how a document database might be used. And so next, we are going to be talking about geographic data, which is more in line with data caching. Let's say we have an application and a user is at a certain point and they want to know all data that is in a certain vicinity of them. So this may be something like food near me. You're going to get some radius of data points that are within some vicinity. So here, again, to get started, I'm just importing some useful libraries. So pandas, which can be used to read CSV data into data frames, Plotly to create a visualization. So I have found housing data on Kaggle, which is a data science site that has lots of open source data. And so these data points, as you will see, have latitude, longitude, and some other characteristics. So to add these geographic points, we can iterate through our data frame and use the geoadd function in Redis Pi. And so to do this, the first argument that we must specify is going to be the geo index that we're going to create. I'm simply calling this locations. You then, in a tuple, are going to provide the longitude, the latitude, and the key name for that location. It's important to note that oftentimes when dealing with these spatial data in Python, many of these libraries deal with data in form of longitude, latitude instead of latitude, longitude. So that can commonly cause some errors. Simply, you can see in these 2 lines of code, we're going to iterate through our data frame and we're going to add that geographic data. So by default, these geo indices are in a sorted set. And so to access those keys, we must call zrange. So remember, each data type has a unique way of extracting the data. So here we provide the index name and we tell it over all of the keys, return them. So I'm only providing the first 5, but you see those are some of the unique keys that we added to our location index. Again, I'm going to call that and just create a list of our locations. And then I am going to call geopause, which is just going to give us the geolocation for that particular key. So if we print that, you see that you get back a tuple with that longitude, latitude. And so all I'm doing here is I'm just extracting all of the location data from our database in order to show what that data looks like, all of it, unfiltered. So you can see here that we have many data points. But one of the cool tools that Redis has is we can do geolocation queries. So for instance, there's a georadius command that we can call where we look in that location's geoindex, we provide a point, we provide the radius that we would like to look around that point, we provide units, and we want those coordinates. Again, that output, it's a list that contains the key and also the tuple with the location. We unpack those into a list, and then we can create our figure. And so as you see, our data has been greatly reduced to that particular point with the radius. And so that's why you see that round little bit of points. While it may seem somewhat silly given the size of this data set, this can save tons of time when you're dealing with this data at scale. So say you have millions of data points and you want to provide, or you want really fast geographical querying of, say, a radius, you can do a bounding box in a rectangle, and it drastically improves speeds. So I have worked on a project before where I initially had data in a MySQL database with location information. Querying that data was slow and it took seconds, which for a user interface is not ideal. And oftentimes people don't want to sit around for a few seconds to view the data. Switching to Redis to allow those geographic queries, it reduced the time significantly. One of the other tools that Redis Stack comes with is it comes with this Redis Insights, which is a user interface so you can view your data. So as you see here, here are all of those document keys that we added. The type, which is JSON, you can click on it. And we see in this pretty printed version here, we have our description that we have searchable, and we have all of these other attributes. You can see there's our locations, which are a sorted set. So this interface can be quite nice when you want to validate that your data has been properly added, it's the proper type, etc. It's also important to note that with the Redis search, there's a bunch of other data types you can do. while I just demonstrated full text search, there's numeric searching that you can do. So if your document has, say, integers within it, you can search for ranges, you can search for exact values. It's really, really flexible. So is the full text searching. I only showed a brief example. So I think with that, we're pretty quick, but I will take any questions.
Any kinds of data that would not be recommended for Redis? Any kinds of data sets that just aren't quite the right thing for using Redis?
Yeah, so I think so relational databases, they definitely have their benefit, right? Especially when you have a lot of data that is kind of related in the kind of a nested format. That is kind of one of those situations where you may want that relational database. Yeah, I can't think of anything exactly that I've come across where it was like, no, this wouldn't fit. I find that most of the time, the data that I work with, at least, NoSQL databases are pretty nice to work with. So whether it be Redis or MongoDB, just due to their flexibility, they're nice to deal with. And also, those solutions can be scaled quite easily. So if you have tons of data, you can set up a cluster where your data are sharded across the different clusters. Those clusters are set up to communicate with one another, which at scale allows for really nice kind of data access.
Time series data would work well, where you have lots of time points.
So one of the modules that I haven't actually looked into myself yet is a time series module for Redis. So I know Redis can support time series data, and they have a specific module just for it. So I'd be interested to look more into that because I definitely think that'd be a cool use case.
Thanks.
Yeah.
You mentioned one project that you had done with geospatial data. Have you done other projects with Redis?
Great question. So far, there's only been one production site that I use Redis for. I've used it for some kind of more personal projects with smaller data. But yeah, so the project that I have used it for is actually in collaboration with Jeremy Kenyon. So yeah, lots of spatial data that you need rapid kind of querying of. That querying is not only geographic, but it comes in the form of numeric values and also text searching. And so Redis has been really nice because you can chain all of those query parameters together and get results that way. So it's been pretty nice.
Would for full text searching?
Yeah.
Is Redis a possible competitor to Elasticsearch, or would it not?
That's a great question. I'm not actually sure. I know that Elasticsearch is so flexible in the type of querying that you can do, and the querying can be so complex that I'm not sure if Redis would be considered a competitor. I know that Redis searching can get really complicated as well. So, but I don't know. Yeah, it's a good question though.